Login accepted.
Okay, I think we can slowly start. People are still coming, but let me start with introducing myself. So my name is Piotr Bochyński. I work for SAP, and since 2012, I'm doing cloud-native applications in SAP. I started with some platform services, with some commerce services, but then we started to build different platforms inside SAP. And this talk is about platforms, about Kubernetes, because we migrated our customers inside our platform from a previous solution, which is Cloud Foundry based, to Kubernetes some time ago. And I would like to share my story, my journey, how our team helped customers, helped internal teams to adopt Kubernetes at scale. Yeah? So this is our experience and what we will talk about. Yeah? So first topic is what is platform as a service PaaS? Why do you need one? How Kubernetes is related to PaaS? Is it a PaaS? Why should you move to Kubernetes at all? And then this war story about our migration challenges, our solutions to that challenges, and what we've learned. And I hope that our learnings will help you to not make the same mistakes we did and make this journey more smooth for you if you are not that yet. So. First thing, what is platform as a service? Probably you've seen such picture several times. Long time ago when I started IT, there was no infrastructure as a service, PaaS, SaaS. Everyone was building data centers, etc. We are now in the cloud world, and everyone uses Amazon, Google Cloud, Microsoft Azure, and that's right now the model. But what is platform as a service? Platform as a service gives you a little bit more than infrastructure, than Google provides, or Amazon or Microsoft with plain VMs. So you have just more automation, more managed services that you can focus more on your application. And that's actually what platform developers do and what platforms do. They relieve developers from these heavy tasks for managing runtimes, middlewares, operation systems, all this stuff. They can focus on their applications. Of course, the next layer is software as a service, but we are talking right now about one level lower. So with PaaS platform, we have the promise for developers that they can become really productive. Yeah? So speed to market is a key here. Yeah? So you've seen probably keynote yesterday that this time to market is really crucial, and you can lose with your competition if you are too slow. So this is also the promise of platform. You can build your application, prototype it, ship it, scale it, and even maintain on production in the cost-effective way with high speed. And of course, there is a price for that. So this is not coming for free for you. You have less control over that. So usually platforms have some opinionated way how you develop application, how you expose, for example, services, how you consume databases, etc. Usually these constraints are similar to 12-factor application. Who of you heard about 12-factor application? Hands up. Okay. By the way, who of you actually use Kubernetes? Okay. So we have half of the room already knowing what I'm talking about, so that's good. And what other problems actually you have with platform is that probably the platform is highly opinionated, then you have some vendor lock. And you need to keep that platform. If you want to switch the platform, it's maybe more difficult. And some examples. So I start from the beginning in the history. And first platform I used was Heroku in 2007. It was 6 years before Docker was invented. So that's some history. Google App Engine next was the most popular one. Cloud Foundry appeared in 2009. It's also before Docker and era, so it's a long time ago. And this was first open source platform that many providers adopted. Then you have a couple of more, and the last but not least is SAP Business Technology Platform. I mentioned that because this is the story I wanted to tell you about our experience in SAP Business Technology Platform that we had. So we started with Cloud Foundry some time ago, and we created this path at SAP ourselves. You can ask why you didn't use, for example, Cloud Foundry from Pivotal or from other provider. Yeah, we didn't. We wanted to avoid the vendor lock from other provider. We have also big requirement, business requirement, that we have to be present on all major cloud providers. So multi-cloud strategy is important for us. There are some legal requirements that we also have. Maybe some of you also share that requirements that, for example, some customers in bank sector, whatever, they need to have data somewhere stored, and you cannot do that, for example, with Google infrastructure because you cannot keep that promise. And what we needed is, in SAP we have a rich ecosystem of systems, applications, business applications, and what we wanted for our developers and our partners to have a platform that is easily integrated with our ecosystem. And yeah, for a big company, and SAP is a really big company, it makes sense from the cost perspective because yeah, we share that cost, and it pays off. So what's the problem? Yeah, so we have this platform based on Cloud Foundry. We have it in the cloud, multi-cloud, so on major cloud providers, even in our own data center. And yeah, but these constraints I mentioned before are too limiting for some use cases. So typical 12-factor application can expose, for example, only one HTTP port, and you cannot do more. And to consume backing services, you need to use Bosch, some strange ancient technology that it's not maybe the best one, and with steep learning curve. And last but not least, Cloud Foundry community nowadays is shrinking. And the future is not so clear. And yeah, we had that impression that we need to go somewhere else. And yeah, buzzword is Kubernetes. Let's go to Kubernetes. So maybe we should build our own solution with Kubernetes. And what is the relation of Kubernetes to platform? Yeah? So you see this infrastructure as a service with this dark blue boxes. You see the things that are already managed for you, and the light boxes are you need the areas you have to provide on your own. So you see that there is infrastructure as a service. So you see that plain VMs. And then you have paths with much more things that are supported. And where is Kubernetes? Kubernetes is here. Yeah? So not so many. What Kubernetes actually does is container scheduling and process healing. Yeah? So if your container dies, it will start the new one. And that's actually it. And you see there is still a lot of things that you miss. Yeah? So you probably need much more to be effective and to achieve this speed to market factor. So Kubernetes is not traditional all-inclusive platform as a service. It's just container orchestration, and this is the quote from Casey Hightower, the author of Kubernetes Up and Running and one of biggest promoter of Kubernetes, that Kubernetes is not a platform. It's a platform for building platforms, and it's just beginning. And yeah, with plain Kubernetes, we have so little, and that's why we have also managed Kubernetes. So we probably used one of them. Who used, for example, Google Cloud Engine? Yeah, you see. So you probably do not want to maintain your own Kubernetes. You can set it up, but it's better to take it from someone who will take care of of operation systems, upgrades, patches, upgrading Kubernetes, all this stuff, providing network plugins and other things. But still, yeah, so we can have managed Kubernetes a little bit more, but still we do not have, for example, way to build your image of your application, enable monitoring, tracing, logging in your application, do some routing, advanced routing, eventing, CI, CD, other things you have to provide. So why Kubernetes at all? So it's not a pass because several factors. I will not explain all of them. Probably you've heard Kubernetes is everywhere right now. So I can skip this any type of application, automated infrastructure management, scalability, running updates, you know that. I wanted to focus more on extensibility, modularity, and consistent declarative API. Actually, I think that this declarative API and extensibility of Kubernetes is a key why Kubernetes is so widely adopted and why it's so cool to keep that as a solution in your platform, whatever platform you use, you build, or you plan to use. This extensible declarative API works like this. So this is the command to get all the resources that Kubernetes manages. This is just the fraction of the resources. You see here basic stuff like nodes, deployments, namespaces, pods. These are the things that Kubernetes manages for you. But how it manages, it's really interesting. Yeah, so the thing is that everything you have here, which if it is storage, if it is network, if it is container, horizontal pod autoscaler, whatever you have in your ecosystem, in your application, you can have declarative state of that resource, and then Kubernetes brings it to that state. And you can do that in consistent way. Yeah? So whatever, this is the kubectl command that you can get deployments, you can get nodes. Everything works in the same way. So you have some API group with version, you have some namespace for namespace resources or for in global name resources, and then you have name of the resources that you want to fetch. And this is the actually REST API behind Kubernetes, because each Kubernetes cluster actually serves all these resources as a REST API. It's classic REST API, and kubectl is just a command line tool for that REST API. And why it is so important? Yeah, so this REST API is declarative, so you do not it works in the way that you declare the desired state, and then Kubernetes works under the hood to bring that resource to that desired state. And this is the example with thermostat. Yeah? So you want to have 22 degrees in that room. You just set 22 degrees in the thermostat, and then you have controller that turns heating or air conditioning and disables that if temperature achieves the desired state. So in that case, if you have 16 degrees in the room, heating will turn off, and this is actually what Kubernetes does. So you do not instruct Kubernetes to turn on heating or turn on air conditioning. You say it's 22 degrees, and then it knows, turn it on, turn it off. And this is the basic pattern of Kubernetes controller. So you see that desired state, so this is this 22 degrees. You see that actual state, this is the 16 degrees. And then you have controller that compares that desired state with actual state and does some actions. And what is really cool that the same pattern works for all the resources that Kubernetes managed. So for example, you create your deployment, then controller in the Kubernetes knows that that deployment expects 5 replicas, then it creates 5 pods for your application with your container, and now, so you do not have a command, spin up 5 containers, you want to have 5 replicas, and then if 2 of your application replicas will die, Kubernetes will pop up, will spin up 2 another pods in that place. So you can just declare that and forget about that. Yeah, so that's the biggest promise. And the same pattern with the same consistent API you can do with your own resources. So you can imagine that actually you can implement that thermostat I gave as an example as a Kubernetes controller. You can add thermostat as a resource to Kubernetes, and you can use Kubernetes API to extend Kubernetes. So with this post to API extensions, you can define your own resource. So in that case, I use the sample, custom resource definition thermostat. I created, if you want, you can find this example in my GitHub. I will show you the link at the end. So it's really easy. You can add such resource to Kubernetes, and then what you need to write is just this controller loop. So you are informed what is the actual state, you are informed about the desired state, and what you need to do is just write simple logic that does the job. And this is, I think, the key of this popularity of Kubernetes, because it's really easy to bring your own controller, and then you extend the API and you can use the same tooling that people already use, so kubectl or any other tools, to manage your extension in the same consistent way. You can develop that controller, you can add it to your cluster, and you can use the same tooling. And there are some examples. I will not show you right now how to build controller. I recommend go to KubeBuilder or Operator SDK if you want to try it on your own. But then, yeah, just if you build such controller, you can easily manage the same your resource in your cluster in the same way how you did it with deployments, nodes, or network policies, for example. And I think this is a key for this popularity of Kubernetes. So this is the report from last year, December, and you can see how many developers use Kubernetes. So yeah, it's big number. I didn't expect to be honest such a big number, and this is 67% increase in last year. Yeah, so it's really getting popular, and yeah, it's going to stay for a while, I think. So this is the maybe the last reason to consider Kubernetes as your platform, because it's really popular. But now let's back to our story. Yeah? So we have this BTP business technology platform in SAP based on Cloud Foundry, and now we want to bring people to that Kubernetes. Yeah? So you remember in the past we had just much more things. We still need to find these missing blocks. Yeah? So Kubernetes is not a pass. You have these missing blocks. We need to bring the gap. Bring these components that are missing. We need to have multi-cloud Kubernetes because you remember we had this requirement that we have to run in every cloud. And this managed Kubernetes from Google will not work on Azure, Microsoft, and vice versa. And Kubernetes maybe it's powerful, but it's also hard to learn. Yeah, so this number of resources I presented is just the tip of the iceberg, and there is much more resources you should be aware of to start building your application. And last but not least, at SAP, we've struggled with the problem that we have really hundreds of teams that are using the platform, and now if we want to manage that solution for them, it's thousands of clusters that we need to upgrade, and all these components that we also have to maintain in that cluster that are these missing blocks. We need also to scale. So that's the challenges and how we solve that. So the first is these missing pieces. Missing pieces can be easily found in the cloud-native computing foundation landscape. So this is the page, you can Google that, and there is about 1,107 projects registered in Cloud Native Computer Foundation today. I checked that number today. And yeah, so there are blocks for everything. Yeah, so let me give the example. So if you zoom in and you go to observability and analysis, you can find, for example, Prometheus here, Open Metrics, Thanos. There are incubating graduated projects, so the larger icon, the more mature solution, but there are plenty of others, like, for example, Grafana here. You can find probably FluentD, FluentBit somewhere, Jaeger for tracing, OpenTelemetry, new cool project. But this is just small thing here. And for other things, you have, for example, for messaging, you have NATS as a solution, which is incubating. You have RabbitMQ, Kafka, other things you can pick. You can find also something for your service mesh. There is graduated LinkedIn, Istio is there. You have Service Proxy, Envoy, popular projects, and so on and so on. Yeah, so yeah, there is answer for every missing block I presented before, but there is probably too many answers. Yeah, so how to pick the right one from 1,000 projects? Yeah, so it's kind of chaotic, and what we want in platform is to not ask all the teams that have the same challenge to go right now and evaluate 1,000 projects and pick the right one. And if they pick something and every team picks something different, probably we will have the nice zoo in the company. So that's the reason that we want to have some opinionation here. So this is our job, actually, to decide which of these components we actually do want, and the opinionation starts here. So you can pick Kubernetes, but then you have to make some choices, and this is about what you bet on and what solutions you will have inside your platform, your solution, that will bring the gap and you make your developers productive. So the answer for that is another cloud-native project. So we have some inception here. You can find Kima project. Kima is the project I work with for last few years. And what is Kima? Kima is actually this group of opinionated building blocks. These are blocks that we take from open source, but also our blocks that we added on top of Kubernetes that build this environment you can develop and run enterprise-grade cloud-native applications. So this is the open source project. Maybe you can be surprised, but SAP is very active in open source. It's GitHub, Kima project / Kima main repository. It started open source 4 years ago almost. And we have also managed services. So this Kima runtime, this Kubernetes runtime is also a part of SAP BTP platform. What we have here, we have these building blocks. We have API gateway based on Istio. We have built-in function as a service, some kind of serverless architecture, lightweight thing for prototyping quick applications. We have eventing based on NATS, built-in service mesh, and BTP service operator. So it is operator that connects SAP services in the way how all the operators in Kubernetes work. And so this way we have these missing pieces completed with Kima project. I will show you later on a little bit demo how it works. But yeah, we pick these pieces and we put it together and we give them to our developers so they have this one problem from their head. Next thing is multi-cloud. Multi-cloud, so running your Kubernetes in Google, Microsoft, or Amazon infrastructure is doable, so you can do that on your own with Terraform scripts. You can set up clusters with VMs, but yeah, we didn't want our teams to do that on their own. If they would use managed Kubernetes from Google, from Microsoft, and from Amazon, this is completely different solution. You need to have completely different scripts or whatever APIs to manage them. So what we did is we have in SAP project which is called Gardener, which is managed Kubernetes, which is multi-cloud Kubernetes, and it is also open source. And Gardener, so you can find it on GitHub /Gardener. It's the Gardener is Kubernetes compliant, so you see the compliance report with from Kubernetes. So this conformance spreadsheet is generated automatically, and you see that the latest versions are supported. So together we have the solution that brings this gap, yeah, solves this gap. Yeah, so we have this Gardener with managed Kubernetes layer, and then we have Kima that provides eventing, routing, observability, image building, and then you can focus on application and on your delivery pipeline. So that's the promise, and how we solve our other problems. So we have the solution, but now we need to push developers there. So what they face is a steep learning curve. Yeah? So when you start with Kubernetes alone is a lot of learning. If you add on top of all these components we bring, so I mentioned Istio, Prometheus, NATS, other things that you need to learn that. And it's not easy. You see a lot of problems ahead of you, and what is actually our goal. Yeah? So this is flatten the curve, popular image, but this time a little bit different. So this is the number of resources you need to learn from Kubernetes at the beginning. And our goal actually with Kima and Gardener is to flatten the curve. Yeah? So that you are a little bit faster, so you can start doing something and you do not exceed your brain capacity with the new stuff. Yeah? So that's our promise. That's how we want to actually solve the problem with this learning. Yeah? So one example. Yeah? Every developer, probably most of the developers, when you develop your first microservice, you want to expose it, have some routing, you want to have some load balancing, retries, some authentication, authorization. And you can do that with installing Istio, configuring Istio gateway, adding TLS certificates. TLS certificates not easy thing because you need to have cert manager. Cert manager you need to have the DNS provider usually, and then you have other stuff to do, like creating virtual service. Then some rules how to request authentication should work, what authorization policy to use. A lot of things to do. Usually this is the challenge for average team for 1-2 sprints to solve all these problems. And what we do, we have some, in our platform, these first things out of the box, and the last one replaced by some abstraction which is called in Kima, for example, API rule. So this is just the one simple rule. I want to have my service exposed in a secure way. And this is the resource we add on top of Kubernetes. You manage these API rules in the same way as you manage any other Kubernetes resources like your deployment. You just add another YAM to your deployment, which defines these rules, and everything is done in the background by Kima component and a couple of open source components like Istio. And this is this way to go faster up through all these steps in your learning with just one single resource. Of course, you still need to know that resource. So how you will find that resource in that big zoo of resources that Kubernetes brings? Yes. So the thing is that at the beginning, you need some guide. Yeah? So how you need to explore this complex world in some guided way. So you need wizards, you need some presets, you need some default values. You want to start with something that actually works, and then you want to learn. So you do not want to spend 2 weeks just trying with different YAML indentation or whatever to figure out what is not working in my application. Probably who can write Kubernetes deployment from memory, not copying anything from the internet? Nobody. That's the right answer. Yeah? So nobody can write Kubernetes deployment. This is the basic thing in Kubernetes, but nobody can do that. You need to copy it from something. Yeah? So that's actually our promise. Yeah? So we give you some way, some UI that you can do that quickly and then learn from that. We believe that this is the right thing. Yeah, so this is the example how you go to the Kubernetes. You go to the namespaces, for example. You want to create a new one, just provide name, create, done. Then you have some statistics about, and you want to write your first code, yeah, so function. We do not want to create microservice, just simple hello world. Yeah, so let's do hello world, just provide the name. The name is the only thing that you need to provide. And actually what Kima does is generates the code, dependencies, configuration, resources setup, so replicas, autoscaler, all these things, these are default. Yeah, so you had to provide just the name. Nothing more. Then you have some resource graph. I will come to that later. And now your function is already deploying, and some pods are created. You can find these pods from the dependency graph. You can see if there are some logs. You can get them easily. You can see that something was pushed to some registry. So we have a Docker registry inside Kima, and this function is already packaged in a container, put as a deployment, and then it's running. And it's there, and you just provided the name. And now you want to expose that. And this is this API rule. What you need to provide is just the subdomain, so the URL you want to expose your function. So nothing more, just the name. And when you create the name, API rule is created. And then you go to the link, and you see hello world. And that's actually the thing. And what we believe is that you need the quick start. You need a way that all these components, Istio, Grafana, Prometheus, all these things are already connected, ready to use. You just start, and now it's time for learning. Yeah? So you have your code already deployed. You can use it. Sorry, I need to switch to the next slide. Okay. And now it's time for learning. Yeah? So when this function was created, you can see from this resource graph, which is also presented in the UI, what actually is created. So you have deployment, you have replica set, you have pod, you have service, and there are other things that you can navigate from that graph, like Istio virtual service. You can learn, but you have something working already. So you know that when you change that, what will happen. When you change the scaling, you know how to do that. Yeah, but the step 2 is when you started with this UI, this is good for the beginning. But each serious developer uses CLI actually. So you work in terminal, in your IDE, and you do not work with UI. Yeah? So this is good for exploring, but later on you need to have something faster. You need to type. And that's the examples. Yeah? So with UI, we also provide the CLI, some command line tools that make it easier for you. So this is the same example, but working with Visual Studio Code, I created alias for Kubernetes with K, so it is a list of my namespaces. I create namespace like before in the UI, namespace demo, and I create a new function, Kima init function, will create some files in my empty workspace. So I will create that function with name test and namespace demo. And you see here, I have 3 files created by the CLI with the package.json. It's actually default function is in JavaScript, but we support also Python. And then we can deploy that, that function to our cluster, and this hello world will be deployed in the cluster. And now you can check the status of the function. It's not built yet. We will wait a little bit as before. But what we can do also, we can run it locally. So local development is also important. Yeah? So you do not want to develop only on your remote cluster because this is slow. There are some tools like telepresence, other things, but it's better to run your code locally. So I changed locally this hello serverless to hello Devoxx local. And then this live reload is happening. And now when I open the new terminal and I can connect to my service and see that hello Devoxx local from my local machine, and I can really quickly develop, just change, save, and run again curl, and it's changed. Of course, I can still bring back the function that I have deployed in my cluster. You remember I had deployed this hello serverless in my cluster at the first line, and now I locally changed that. Let's sync it back with the content that we have on the cluster. So there is, the function is already built on the cluster. I will download the function back to my local system. So Kima sync actually will sync that, that function back from the cluster. So there is the state before we change that. And I'm taking that function from the test namespace, from the namespace demo. And then when I execute that, you see hotly, so the previous function is already loaded in my environment. So this is the next step. So we believe that yeah, you need to start with the UI, but then you migrate to your environment, you develop, you can do that quickly. And that developer productivity is the number of iterations you can do. Yeah? So it's the faster you can be, the more productive you are. Yeah? So so that's the next thing, and of course that's development. But later on, when you finish with the development, you probably will put everything again in CI, CD pipeline, so all these things that you had, you will have in your GitHub. This function will be in GitHub. We have the possibility to automatically fetch the new versions of the functions and build them automatically. You can do that, of course, in your way. With your CI/CD, you can just produce the function YAML, and then you can apply it with kubectl apply. So that's the regular way when you do that already on production. Yeah. So we covered day 0, day 1 of software lifecycle, so starting with exploring stuff, then with development. But the hard part in software industry is actually the Rust part, so keeping that up and running. Yeah? So it's easy to develop Hello World application. It's easy also to develop any other application, but maintain and keep it really scalable and update it and monitor it and keep it up and running is hard. And for that, we also have the solution. Yeah? So this application, when you deploy it, it comes automatically with dashboards. You see the number of requests, CPU, it recognizes your error codes, everything. Because we have integrated Prometheus, Grafana dashboards, we have also tracing, so you can see how requests are coming through your microservices. And we have also logging included, so you can also search for logs and etc. And it is out of the box. You do not need to write anything. And you have rich statistics of your application because we integrate Istio service mesh. So it's for each application you deploy, you have a sidecar which intercepts your traffic, and then you can have all these statistics out of the box without writing even single line of code. And this is this productivity we promise to our customers. So now you have everything, you are productive, you can learn fast, and you have all these missing pieces, you are running on multi-cloud, and now the problem is, you have security patches for all these components, Istio, Grafana, Prometheus, other things, NATS, you have operating system patches, all this for different cloud providers, a lot of work, and we need also to scale that. And this is the full-time jobs, just to keep up with security patches. And if you multiply that with the number of teams, and we have really hundreds of teams that are doing that, it's really the high cost. So we had to find a way that we automatically manage these thousands of clusters for our teams and our partners. This, what we actually came with is that we automated everything. Yeah? So this is our promise that you do not have any manual step to keep up with all these security patches, Kubernetes upgrades, all these things. It's done for you automatically. How did we do that? Remember this Kubernetes controller pattern. Yeah? So I talked about that earlier when we talked about the native Kubernetes resources and extensions. So still, we want to use that Kubernetes pattern also for that purpose. So you have this desired state, this temperature, and this actual state that you have. And in the same way, we manage these thousands of clusters in our platform. So you can imagine that cluster is an object, and Kima components, all these components, these open source components and our components, is also the object that we manage. So this is you create such object in Kubernetes cluster, and this object represents the desired state. So you want to have cluster with minimal with minimal number of nodes, 2 and maximum 15, for example, with autoscaling, and you want to have Kima installed with Istio enabled and NATS eventing enabled. You just declare that, and then Kima operator does it for you. So it spins up the clusters, installs the software, and when the software is changed, the upgrade comes, it watches the current version, updates it, and does it continuously without your intervention. So we use the same pattern to manage multiple clusters and multiple Kima components installations in that cluster. that's it. It's done. So we solved all the challenges I mentioned at the beginning. Now maybe some failures. Yeah. So not everything went so smooth. Yeah. So couple of things that I wanted to share with you that you do not make the same mistakes. We tried at the beginning hide Kubernetes. Yeah? So you remember we had this cloud platform, Cloud Foundry platform, and we were thinking that maybe we will hide Kubernetes. We will have the same API like Cloud Foundry provides. So you have a Cloud Foundry push command, and then your application is there, and we will hide all these networks, pods, all these things from the user. We will just have the same. But that was wrong. Yeah. So because people want to use Kubernetes because they want to have control over these resources, and that's why we quickly gave up this idea of hiding that Kubernetes. We had also the idea that we want to manage these clusters. So it will be much easier to manage clusters if users, customers do not break too much or do not configure too much. So we know what is the environment. And we started also with the idea that in the managed cluster, you do not have cluster admin role. You have just your namespace when you can push some, you can deploy some pods, some deployments, some services, but you cannot go outside. You cannot extend Kubernetes with your own custom resource definition. That was also wrong, because people really want to learn, so they can start with this limited functionality because they don't need that. When they write hello world, it's okay to have predefined settings and no single opportunity to modify anything in the Kubernetes. But later on, when they learn, they want to go outside of these limits that they had. And going outside these limits is the main point of using Kubernetes at all. And we had a couple of wrong bets. Yeah? So you've seen these thousands of projects we picked. Most of them were chosen, these choices were okay. Some of them were bad. Yeah? So for example, there was project service catalog in Kubernetes SIG that somehow represents cloud services and any services in Kubernetes using Open Service Broker API that was used previously in Cloud Foundry. So it was kind of porting Cloud Foundry services to Kubernetes. It turned to be not efficient enough, and Kubernetes word picked operator as a main pattern for delivering external services, and this project is actually retired right now. We contributed to that project, so that was kind of wrong investment. Also, a couple of components we picked from Grafana. Grafana recently changed the license from Apache to AGPL, and we have now to migrate to something else because we cannot also ask all the customers and teams to pay that price for each single cluster. So that's a couple of wrong things that we did. But in the end, I think it's these failures also, we could fix that in single team. So all the teams that depend on us actually are better because we found these failures, we fixed these failures, and now they can just benefit from our learnings. And summary, takeaway. Kubernetes is going to stay for a while, so learn it. You need some sort of platform. So it doesn't have to be named platform as a service. It's usually some guy in your team that just does the work, or just the team, several teams that are doing that groundwork and doing all this stuff for you. Building your own PaaS is expensive, so if you can get something from the market, do that. And if you can find platform that is Kubernetes based and gives you a lot of freedom, pick this one. And last but not least, Kubernetes controller pattern is very powerful, and I recommend that you learn it and use it if you have similar problems. So last thing, you can win such headset and you can ask questions. Today, in 15 minutes, there is a draw in SAP booth on first floor, and you can find me there, and I can answer your questions because we are out of time now. So, thank you.